So, rate constant or specific rate. K is rate by concentration of reactants to the power n. Okay. So, rate of reaction. What is rate of reaction? Change in concentration of reactants or products in unit time. Okay. So, here R is concentration by time. We can indicate R as concentration by time. So, K is equal to C by T, concentration by time, okay, into 1 by, what is square brackets indicates here? Concentration only, okay. So, 1 by C to the power n, okay, we can write like this. Rate is concentration by time, rate of reaction, change in concentration in unit time. Okay. So, by concentration of reactants to the power n. So, we can write C by T into 1 by C to the power n. Okay. And this can be written as 1 by T into C to the power n minus 1. Okay. 1 by T into C to the power n minus 1. Okay. So, here CC gets cancelled. That's why 1 by T. 1 by T, what is T? Time. If we take 1 by T as second inverse. Okay. So, second inverse. Concentration we can write moles per liter. So, 1 by moles per liter. So, it is liters per mole to the power n minus 1. Okay. So, we can write second inverse. Okay. Then liters per mole to the power n minus 1. Okay. So, from this units of K, that is equal to liters to the power n minus 1, moles to the power 1 minus n, and second inverse. Okay. So, what is n here? Order of the reaction. So, units of rate constant that depends upon the order of the reaction. Okay. Then, if gaseous substances are there, okay, and units for gaseous substances, we can write atmosphere second inverse. Okay, atmosphere second inverse. Okay, but generally units for K, specific rate or rate constant, so that is given as liters to the power n minus 1, moles to the power 1 minus n, and second inverse. So, n is order of the reaction. For example, if n is 0, okay, 0 order reaction. For 0 order reaction, okay, so units are liter inverse, mole, second inverse. Okay. If n is 1, n is 1, n is 0, n is 1. So, first order reaction. Okay. So, for first order reaction, liter to the power 0, mole to the power 0, second inverse. So, units are second inverse. If n is equal to 2, okay, then for second order reaction, so units are liters, mole inverse, second inverse. Okay. So, by substituting n value, can give units, specific rate or rate constant units for any type of reaction. Okay. So, this is about rate constant or specific rate. Then coming to some objective bits related to this. The specific rate constant of a reaction depends on, so rate constant, you know that rate constant of a reaction is independent of concentration, but it depends upon the temperature. Okay, so here the specific rate constant of a reaction depends upon the temperature. Option C. Okay, temperature. Next, the unit of rate constant depends upon. So rate constant units that mainly depends upon the order of the reaction. So what is rate constant? K is equal to R by concentration to the power N. Concentration of the reactants to the power N. So what is N here? Order of the reaction. So mainly units of specific rate or rate constant that depends upon N value. Okay. So it depends upon the order of a reaction. Okay. Then the temperature coefficient of most of the reactions lies between. So temperature coefficient mu, that is equal to K T plus 10 degrees centigrade by K T degrees centigrade, that is equal to 2 or 3. Mostly it is 2. So rate of the reaction, so that is increases as for every 10 degrees rise of the temperature. Okay, so rate of the reaction becomes double for every 10 degrees rise of the temperature. Okay, so that's why it lies in between 2 and 3. Okay, mostly 2, and for some reactions it may be 3. Okay.